the following example, we're going to create our own SubVI to do something very simple. We're going to create a SubVI which calculates a squared plus b. So in this case, our SubVI is going to have two numeric inputs, otherwise known as numeric controls, a and b, and one output, one numeric indicator, which we're going to call output. So now we're going to go to our block diagram and simply create our code. So from our numeric palette, we're going to choose multiply. We're going to wire up a times a. Then we're going to choose add from our numeric palette. Add b. And connect the result of that to our output. So you see now we have our front panel and our block diagram to simply calculate a squared plus b. Next, we're going to save our VI. We'll just call it Custom Math SubVI. So now we've created a VI. We can test it if we put a equals 2 and b equals 3. When we run it, we get the output of 7, a squared plus b, is indeed equal to 7. So our debugging process is complete, and we know that our SubVI works. So next thing we need to do in order to use this as a SubVI is we need to properly define the inputs and the outputs so that another VI will be able to call it. We access this via the icon. By right-clicking in the icon window, we can see we can choose to edit the icon and show the connector. Let's start with editing the icon. This brings up the LabVIEW icon editor, which allows us to very simply create an image which represents this icon. We have the ability to use a pencil, a line tool, the eyedropper and paint bucket, rectangles, a selector box, and a text tool. Very familiar tools as you would expect to find in any paint program. We'll just create a very simple icon here. What I'm going to do is just create a colored rectangle with some text inside. So I'm going to choose my background color first. That is the backmost of the two colors here. We'll give this a red background and a black outline. So we can now use the rectangle tool to select and draw a rectangle. And notice how the rectangle is filled in with the background color and has the foreground color as its outline. There's a shortcut which you might find quite useful, which is to double-click on the rectangle icon, which automatically draws a rectangle which covers the entire area. Next, we want to put some text inside it. So we choose our text tool, but before we actually create the text, let's select a font. Double-click on the text tool to bring up the fonts. If you're running Windows, there's a font called Small Fonts, which you will find already existing in your system, which is very useful for creating icons because, as is no great surprise, it's a very small font. So we choose a size of 8, alignment left. Again, you can choose whether to set the bold, italic, underline, various other options of the text. Also at the bottom here, you can choose whether to assign this particular selection as the panel default or the diagram default font selection. Leave those deselected and leave the style as plain. When we click on our text tool, we can type in Custom Math SubVI. Also, another hint, which you may find quite useful, is while the text is still actively being entered, you can use the arrow keys on your keyboard to move the text around. We also have the option to set icons for the 16 color and the black and white representation of this icon. Choose the 16 color icon and select to copy it automatically from 256 and do the same for the black and white. Now we click OK and notice that our icon now properly is represented by the icon we just created. The benefit of creating the icon is to make it very easy when calling SubVIs to see what each SubVI does. You'll notice that the LabVIEW built-in functions have icons which very clearly represent the behavior of each function. The second task we must do is now to define the connector. Choose Show Connector to toggle the display from the icon display to the connector display. Notice what we have here is a representation of a series of inputs and outputs. Notice here how we have 1, 2, 3, 4, 5, 6 on the left and 6 on the right. It is not necessary, but it is generally the case that we define our inputs to be the leftmost side and the outputs to be on the rightmost side. So what we must do is map the inputs and outputs of the SubVI onto the connector. The way to do that is using the wiring tool. First click on the desired connector, then click on the desired control. Notice that once that was done, the connector position becomes colored, and in fact it is an orange color, which represents the fact that the input is a double precision floating point number. Now we'll wire our second input, B, and we'll wire our output to the right-hand side. We return now to show the icon, and we save, and now we have a SubVI which can be used in various other VIs. One other important point about SubVI connectors is that you can select a different type of connector pattern. By default, this particular pattern was selected for our new VI. However, if we right-click, we have the option to select amongst various other patterns. You might notice that because this VI only has 2 inputs and 1 output, we have a lot of unused connectors there. So we can pick a different pattern. In this case, we can pick one with exactly 2 terminals on the left and 1 on the right. Notice how LabVIEW has automatically reconnected the terminals which we had previously connected to the terminals of the new pattern. As long as the number of terminals on the new pattern is less than the previous number of terminals, LabVIEW will be able to do this. There are some other options that you can access by right-clicking on the icon menu. You can choose to remove or add terminals. You can choose to rotate a pattern. You can also choose to flip a pattern either horizontally or vertically, or disconnect terminals, either all terminals or individual terminals. One additional important point about the connector terminals is that when we click on one terminal, notice how the linked control is automatically highlighted. It's a very useful way to double check that everything has been connected properly. Similarly, when we select a control with the wiring tool, notice that the relevant terminal is highlighted on the connector.